So I'll kick it off here, but Jason will actually be doing more of the heavy lifting. So what we wanted to present today is leveraging drilling data on the completions phase. So, as a company, part of what we do and what he'll show as a part of drill to frac is, all this drilling data, how do we aggregate it and how do we make it actionable, especially when we have completions designs, for operational performance as well as getting a better frac. So what we're going to go through, and I'm going to cover really just kind of as a whole industry level, the overall integration between drilling and completions and how that process coalesces and works. And then Jason will go through and cover drill to frac solution and really the applications they've built through the Corva architecture to display that and help operators, as well as a software demonstration from that standpoint. So what we're showing here is really just the integrated platform that Corva has for drilling and completion. So as Corva, when we started, drilling-based platform, so drilling analytics, real-time, monitoring, hazard avoidance optimization. At this point, we're 65 plus different apps. And really, we want to show both of these features to kind of show how far completions has gone and really how they both merge and coalesce. So really within, drilling commercially about four years that it took to build all of these applications, whole variety. Completions has only been around, we're looking, maybe close to 2 years as a commercial product. So the level of different applications, what we've been able to do and build on that side, it's almost 2/3 of the amount. So it's just showing, how we're able to help build applications. And that's going to really be shown, as you see the demonstration of the software, how Corva architecture was used to build a drill to frac app and how that all coalesces. And again, because all of this drilling data is within the platform, it's very seamless. It can be easily used and utilized for the completions design, for applications, for products from that standpoint. So let Jason go ahead and cover various pieces that he has on the specific app, as well as their process.
Thank you, Michael. So from my perspective, one of the things we see is, as a company, we see a lot of valuable information in drilling data. And one of the unique aspects between Corva is already been demonstrated is they have both the aspect of the drilling data that's all in one place and consolidated, and they also have a lot of the completions data presented at the same time. So we saw a lot of benefits in that, one, we could source the information that we need to do our process from Corva and also from customers for ancillary data. But then finally, when we're done working our process, that we can push it back to the Corva platform so that way it could be displayed side by side with the treatment information. So essentially, that's what we're looking at and I'll demonstrate a little bit about what drill to frac does. I'm going to stay at a very high level. That's not what this presentation is more about. This is more about how we take what drill to frac does, put it together, and then how we partner that with what Corva already has inside their infrastructure. So the app itself, just kind of a high level, is meant as a visualization tool. So we pull, as I said, we pull the data directly from Corva, and then once we have it, we work our normal processes with it, do a lot of analysis, and I'll talk a little bit about that, come up with a couple outputs that are part of our normal standard deliverables, and then we push those deliverables back to the Corva platform for visualization. So I'm going to start with just a little bit about our drill to frac process. So starting with just something that, for those who are not familiar with, MSE is a very common, mechanical specific energy is a very common attribute, something that if you go to Corva's platform right now and you look at the drilling data, there's an automated mechanical specific energy value that comes out. What we found is that the challenge with that information is it mixes both the rock attributes, so compressive strength, along with drilling efficiency together. And so it's, for our purposes, we want to know about the rock. We don't necessarily want to know about the drilling efficiency. So our big part of our process is to go through and remove the effects of drilling efficiency, basically to normalize them out. So then what I'm left with is rock MSE. Rock MSE is the basis of all our products later on. And the idea is that now I can compare along a lateral and from one lateral to the next how hard that rock was. The harder the rock was, the more energy it took to drill a foot of rock, then it would be harder rock to deal with. And heterogeneity is another thing that we can see with this, is just how much that rock is varying along the lateral. And that also plays into our process. So I'll talk a little bit more about that. But ultimately, the process, as Meg did when she introduced at the very beginning, it takes time, right? To do it properly, if you just take straight information from the drilling platform and just run with it and use the MSE, what you'll find is it's really noisy. It's susceptible to a lot of different conditions that are going on in the drilling environment that are much more factors of drilling efficiency. And so that's why the process usually takes a couple days to work through the process and get cleaned up data that then gets put back into the Corva process. So we've been doing this for a while. We're doing this for 7 years, and we have over 1,000 wells. The whole principle of this and why Corva's relationship is so valuable is that we don't use there's no tools. It's all drilling data. So you don't need to do any additional logging or anything else going in the well. We just take straight drilling data. And as you can see, there's some customer comments here. It's useful. It is actionable. The thing about it is sometimes seeing is believing. And that's where the Corva app makes it a lot more actionable and usable. When I can put this information alongside how that stage is treating, now I can really make it powerful. One piece that I'll hit at a very high level is depleted fracture identification. It's something that we've been working on very hard lately, and it's a refinement on the OmniLog or the rock MSE values that we get. And what we're looking for is special or specific unique signatures that are present in the drilling data that identify when there's depleted fractures present. And we have seen reliably, repeatedly, and with lots of evidence looking at other logs and other data that we can see that depletion. So the excellent point is being able to take this information and know when we're going to likely have interactions from well to well and have an impact on that particular stage of that treatment. So the idea is to use this as a stage-by-stage attribute that we can then see proactively it's coming up and be able to take corrective action before it happens. Now, there's lots of different ways to take corrective action. We can talk a little bit about that some other time, but the key thing is those are all dependent on the operator themselves. What is their special sauce? What works best for them? Is it diverter, moving perforations, just changing where they have the stages themselves? There's lots of different ways of dealing with that. But the key thing is knowing that it's coming, being able to see it proactively. You can take steps to take corrective action, come up with a mitigating plan. And so this is basically just to follow up with one of the key things is with a lot of this information, the more wells you can do this on, the more confident you can feel that it's giving you something real. And the low cost and the fact that you don't have to put a tool in the well, and by having a relationship with Corva where the ability to pull that data is smooth and clean, and then be able to visualize it and test it and make sure that it's working, that piece makes it where you can learn a lot quicker. And you can take old data and compile it with what you already know and get better and better without having to repeat the same mistakes over and over again. So this is where we see the value is being able to learn inside the same well, this real-time application of being able to have this information sitting alongside your treatment data. And when you come across a troubled stage, a stage that has some type of hazard that we've identified, then you can know that it's real. You know that it's material. And then when you look down your well in the future stages that are coming, and they also have similar challenges and similar hazards that are identified, you can, even if you didn't believe the data before, now you have in that well, in that near real-time decision-making, you can make a mitigation plan to deal with that problem for future stages. So ultimately, this is just a small demonstration is being able to say, okay, I have a whole bunch of information and I come up with a couple flags that give me an idea that I have a couple stages, they're gonna have problems. And when I come to them, I already have a plan that, okay, in this particular case, it's saying it's a high rock MSE. It's a particularly large outlier from the normal stages. So then I can say, take proactive steps ahead of time, say, if I see a particular pressure signature with the alarms that you can get from Corva, the benefit of that is you can set alarms, and when it comes up and says, hey, we're having trouble treating this stage, then you can easily see, okay, what is the attribute that's causing that challenge? And then take a more targeted way of dealing with it. Instead of just instinctively running and putting more acid in the well or going to a dirty sweep or something, you now have an idea of what is causing that failure or that challenge with that treating that stage, and you can take a targeted action to improve it. So also when you see a different well, so this is a different example, and over on the right-hand side, we can see that the completion hazard risks are, again, more of a yellows. You see a little bit more of the outliers present here. So this well, compared to the first one, looks like it's going to be a little bit more trouble to treat. And what we see here is LHI. So LHI is lateral heterogeneity index. So this is basically how heterogeneous those particular stages are. One thing that's interesting, if you look at this a little bit closer under rock properties, there's LHI, there's some blue and some reds. The reds under LHI are high values. The blue values are low. One thing that's interesting is the reason we talk about outliers versus magnitudes of high or low is because most operators, when they're dealing with a particular reservoir, they know how to treat it well for most of the stages. So for 80% of the stages, they've got a treatment design that executes very well. But sometimes they've got a design that's really good at dealing with heterogeneity. They've put a lot of clusters in there. They have diverter. They're doing every action that's really good at dealing with heterogeneity. But the reality is their well is really homogeneous. That particular stage is very homogeneic. And you can actually have trouble treating stages that are homogeneic when you're designed for a heterogeneic stage. So that's why when we look at these, we're looking more at the outliers, the things that are different, either low or high, so that way it can give you an idea what you're getting yourself into. So that's just basically, and in stage number 7 here in particular, if you're looking at that and had an idea that it's coming up, you could take some action, because not only do we have a good amount of heterogeneity, but there's also harder rock. The lithology is changing. There's a lot of things that are going on in that particular stage that gives you a really strong confidence that that stage in particular is going to be relatively difficult to treat. And you can come into it, imagine that stage is at 2 a.m., right? That's usually when the bad things happen, is at 2 a.m. Well, at least you know when you're going to bed at night that that's the stage that's coming up at 2 a.m., and you can already have a plan in place on location. That's the power of being able to have these types of hazard identification ahead of time. All right, so let's get to the app, because the app is actually the really cool thing. So, all right, let me show you here. Okay, so there's a lot going on. Don't get me wrong. We tried to capture overall what our normal log delivery is, at least all the various curves in it, and then give as much control to the user as possible. The benefits of this particular app is that each user, when they load this data and when they're dealing with working with the app, the settings for it are individual to them. So if they want to change a particular scale or change the order of the curves, or they want to manipulate it to make it look like what they want to see, luckily their colleague who's just down the hallway who wants to see it a completely different way isn't stuck looking at the same view. So that's one of the benefits. Just some basics of what we're looking at here is right now we're looking at an asset. So the idea is that you log into Corva, we have already provided you with a JSON file that is uploaded. There's a little faint cloud icon you can see over here. This is actually the way that the data is uploaded into the app. The good thing is that either we can do it for you or you can do it for yourself, depending on how much control or access you want to give us to your account. If you do it yourself, it'll work the same way. All the settings for the different curves and all the color coding and everything else comes inside the JSON file, so it's easy for it to be set and customized before we hand that file off to you. And then once you get a hold of it and you want to change some things, you can very easily change those things. Let's see here. So some of the basics of the app is what we're looking at right now is the whole stage, the whole well, from top to bottom. At the very top, you can see zoomed out just each one of the stages with the stage breaks built in. Also in here is mud logs. There's various curves that are coming from the data. But in particular, one of the things that I like is, let me go through it. So here we have rock MSE, we have gamma ray, we have lithology, so just straight from a mud log, the lithology. Also, this is the fracture identification that we've done with the depleted fracture identification process, so that's identified here. And then those hazard flags for each one of the primary categories. So rock MSE is basically an outlier for if the average rock for that stage is high or low. Heterogeneity is that lateral heterogeneity index, if it's particularly high heterogeneity or particularly low heterogeneity, and then the localized depletion. So one of the stages in particular that we can see a flag for heterogeneity, or sorry, for depletion is this one where we have this particular anomaly for depletion. But overall, as far as manipulating the app itself, I don't like having the fractures at the bottom. I prefer to have them at the top, just below the mud log. So I can come in here, and I do need to kind of move around here. Oh, wrong spot. So it's this little gear icon. Once I'm on the gear icon, it shows me all the different options. We can see, for one, that the lithology, it's not bringing very much information at all. It basically is all shale, or was that lime? I think it was all shale. So we can go ahead and turn that off. When I turn that off, it goes and hide it. I have a limited amount of territory here to be able to see something useful, so I can go ahead and turn that one off. But also, I want to go ahead and put these up here. I'd like to have the changed where those that track is showing up. So I can push on this little, it's almost little 6 little dots sitting next to each other, and it gives the ability to change what order those tracks are shown. So the other thing is, I'm not particularly fond of how wide the fracture anomaly is. I can narrow that particular band. Also, mud log, I would rather have it also a little bit narrow. So these are things I can easily manipulate and change with the app. And then finally, I would like to view and zoom in and see maybe a series of these stages. Instead of seeing the whole well, which is nice to see an overall picture of the well, but maybe I'm concerned about this particular stage in stage 17, and I want to see what's coming up in there. I can click on this period or the selection, and then I can put in custom, and it will give me a range of stages in which I can see. And when I zoom in enough, there's a range which, we only can see the information correctly, is being able, once I've zoomed in enough, maybe 5 stages or so, now I can see these little pips. This is actually where the perfs are as well. So we can see where the stage breaks are with these longer lines and the little bit more distinct, or this taller line where the stage break is occurring, but also where the individual perfs are sitting. So if you wanted to see what the rock was like in each one of these perfs, you can easily see and detect that and be able to see it in a visual way. And also now I can see that I've got this particular depleted fracture. When we're classifying depleted fractures, one of the things we do is we give them 3 different classifications. One's low confidence, high confidence, and very high confidence. The principle is that drilling data is messy, and there's a lot of stuff going on. And sometimes there's uncertainty about what that particular anomaly. Is it really due to depletion, or is it potentially due to changes in lithology or some other condition? So when we have some level of uncertainty, that's indicated by these 3 different weightings for the depleted fracture identification. And in this particular case, when we're seeing very high confidence, usually that's supported by some offset wells, where we're seeing that particular, between high confidence, very high confidence, we would classify those as actionable, meaning that we see that there's a strong potential that the extent of that fracture is long enough and the depletion is large enough that it could have a significant impact on the treatment of that well. So that's just kind of a classification on the fractures. And then one of the ways we can view this information is the power of, if you haven't played a lot with Corva and playing with dashboards and manipulating dashboards, the power is being able to have different apps and putting them side by side. So taking information that is already present in a treatment plot and then being able to put it right beside, like we've shown here with stage 17. Now, obviously, this is a mock-up where, hey, this is a treatment plot. This treatment plot really isn't from this stage. However, it is absolutely something that you can do, where you can say, I'm currently fracking stage 17, and there's an option for current. And it actually uses this WITSML type query language to look to make sure that it's both apps are using and looking at the same well and the same stage. So it makes it very useful to be able to do that. And then if you wanted to change and be able to look at a more custom range and see what's coming up in the near future, you could easily come in and change the stage numbers and be able to adjust that view without any problem at all. That's what I have so far as the, are there any questions?